Hey, hello guys, welcome, vanakkam, vandanam, namaskaram. Today we are going to see such an amazing lesson. Well, I know I am always using that particular notation that this lesson is amazing. Well, every lesson is amazing in their own way. Okay, it is just the amount of interest that you have. Here now, today we are going to see about electric potential and the capacitance. Okay, so this lesson and the first lesson, that is going to be the electric field is there, right? So that lesson and in this lesson, the first lesson will be completely kind of tough only. The second lesson half alone will be kind of tough. Okay, from the capacitance, the total toughness of this physics itself will be gradually decreasing. Only the first lesson and the half of the second lesson will be kind of tougher, then after that the toughness will be decreasing. That is something that is said by my physics sir, because I don't know how other lessons are going to be, but I genuinely, I completely, I 100% believe my physics sir. Okay, so yeah, from here the toughness will be there till capacitance, and I've already uploaded the video about capacitance. Okay, what is a capacitance, what do you all have to know about capacitance, all of those things I've uploaded. Then the next video is also going to be about capacitance, where we are going to see what are the formulas that we are having in capacitance, all those things is, well, in this video we are going to focus about electric potential. Okay, potential difference, work done, all those things is we are going to focus. Okay, and I hope if you are seeing part 2 or part 3 or part 4 of any lesson of any chapter, okay, of any subject, then I will prefer you all to see part 1 first. Okay, because part 1 will be having, literally it's kind of the one shot video that you need for rest of the total episodes or for rest of the total parts. Okay, so this first part of every lesson is going to be the basic thing. Okay, it's going to be the base foundation for rest of the remaining episodes or parts. Okay, so this is just an advice that I would like to give. Now we will be getting started with this one, electric potential difference. Okay, so first we are going to check about electric potential. What is electric potential? First, what is potential? Normally we use this word potential a lot, right? For an example, in physics, even I'll be saying in physics, the potential energy we use, right? Like it's an energy. Okay, so now you're having a ball over here. As the ball increases, goes high, goes high, goes high, it will be having high potential energy. Okay, potential energy will be increasing with respect to height. We have already seen all of this, right? Because potential energy is mgh, all of those things is when the ball is being dropped from here, so it just comes by kinetic energy, and then the potential energy decreases. All these things we have seen, right? Okay, so what does this word potential mean? Potential mean capacity. It is the capacitance. Okay, it is the capacity. It is not the physics capacity, it is the English capacity, the epitome, okay, the capability, the ability, all of this thing is what we'll be saying it as the potential. Okay, so here this particular ball is having the ability to come from this point to the ground level with this kinetic energy. So that is why we have kept it as potential. Okay, this ball is having the ability to come with this particular kinetic energy with this particular velocity when it is kept in this height. So that is why we have given it the word as potential energy. How great is it? Okay, so this is just an explanation so that you can understand what is actually potential. Potential, here the potential is also about the ability only. See, potential, just increase the size so that you can just see it better. Okay. So what is there? There is actually plus q charge. Okay, you have kept plus q charge in a point. Okay, let this point be C. Okay, let this point be C. So in this C point, you have kept a plus q charge, and then there is this B point. Okay, there is this B point, and then there is also this A point. In this A point, what you are doing is actually in this A point there is a unit positive charge. What is the unit of positive charge? What is the unit of charge? It is going to be 1 coulomb. We have already seen it in our electrostatics. That means in our electric potential, we have seen it in a very clear cut way. So like that when we here also. So we have kept here a unit positive charge in this point A. So from A to B you have to move it. Okay, from A point to B point you have to move it. But unfortunately, since there is this plus q charge, okay, plus since there is this plus q charge, there will be some sort of repulsion force that will be exerted by this charge against this unit positive charge. Okay, here is where the charge is. That is what I have represented as 1c. My handwriting is kind of terrible. I'm so sorry for that. I'm just improving day by day. Okay, so from this point to this point, this charge has to move, but there is a repulsion force that is in this direction. Okay, but the movement that we require should be in this direction. Okay, this charge has to move in this direction, but there is a force. So you have to do some amount of work then. Okay, some amount of work should be done to move, in order to move this one unit positive charge from this point to this point. Yes, right? So that work done is what known as potential. That is what known as potential. How easy is it? Very easy, right? Okay. So now we are going to see about remaining things. I will just, okay. So this point is C point. Okay. So let this total distance from C point to this A point be x. Okay. Let this total distance from, okay, so from the C point, from this C pointer to this B point. Okay, this, let this distance total be x, and then the distance between this A and then this B be dx. Okay, so this is what the definition is. In 2 mark questions or in 1 mark questions, they can ask you the definition. Here it is. It is the amount of work. It is the amount of work done to bring a unit positive charge from one point to another point against the electric field. Okay, against the electric field. Okay. So potential. They see potential, voltage, potential difference, and EMF, electromotive force. For all of these 4 quantities, the SI unit is going to be voltage only. The SI unit is going to be voltage only. I pardon myself. I repeat myself. Potential, potential difference, voltage, and then EMF, electromotive force, and also electromotive force. For all these 4 quantities, the SI unit is going to be voltage only. So don't not forget it. Okay. See, from this point even we can easily get the formula. The formula for work done, okay, or the formula for voltage is that, see, you have to do some work done in order to bring this charge, right? So work done per charge, work done to move a charge. Yes, right. So that is what the voltage is. So voltage is equal to work done per charge. So the amount of work done to move a charge. That is what the formula is. So voltage is equal to work done by charge. So work done is equal to voltage into charge. Okay. So the SI unit is going to be for work done. We all know that SI unit is, okay. So for work done, we all know that the SI unit is going to be joules, and for charge we all know that SI unit is going to be coulombs. So in order to bring it to the top, you have to put an inverse. So joule coulomb inverse is what known as voltage. Okay. Next is, see, electric potential. What is this electric potential? What is the difference between normal potential? What is this difference between electric potential? It's actually very simple. Here what we have seen, right, this electric potential and then this potential is there, right? Actually this is actually known as a potential difference. This point is not known as potential. This is not just simply known as potential. This total thing that I have explained, right, that is known as potential difference. Okay, so that is known as potential difference. Then what is electric potential? So what is this potential? Here it is simply said as potential, but here it is said as, in this case it is said as potential difference. Why is there such sort of difference? What is the need for such sort of difference? See, when it is between 2 points, when it is between two different points, see, there is in this case, okay, in this case we had taken point A, point B, sorry, or point B and point C, right? We have taken 2 points, right? So when you are taking points, okay, when you are taking points in the order, then you have to say, or when you in that case you have to use the term called as potential difference. But when it is actually a point and an infinite, when the word infinite comes, then you have to use the word called as potential, just the electric potential. That is the word that you have to use. Okay. See, there is one unit positive charge. that is actually in the infinite point. So you have to bring it to this point P. Okay, so this point is known as point P, and then there is also another charge that is literally r distance. Okay, that is in r distance from this point P. So that charge is also positive. This charge is also positive. This charge is also positive. So when you are bringing as it comes closer, there will be some sort of repulsion force, because this is also positive and this is also positive. Okay, so here the same, see here I've given you the dimensional formula. The voltage formula is going to be the same, only work done per charge. Okay, the one and only difference from there to here is that this value will be kind of higher. Here this value is going to be kind of higher. So in order to represent that higher lower only, I have put here dw. Okay, dv and dw, the variables you have to integrate in this point, but here there is no such sort of thing. I haven't put anything like that. Okay, so coming to dimensional formula or dimensional analysis, it's going to be m power 1, l power 2, t to the power of minus 3, and ampere inverse. That means ampere to the power of minus 1. So this is what it is going to be. If you want the derivation, see work done is equal to force into displacement, charge is equal to I into t, which can be written as ampere 1 and t power 1. And in force, see for force, it is actually mass into acceleration. Acceleration is going to be lt minus 2, that means L power 1 T power minus 2 into mass, which is m1. So it's, if you're just getting it like that, you'll be getting it. Okay, then the relation between electric field and the potential. What is it? What is the relation actually? See, this relation I will be saying, but now even I'll say the important thing. Then we will be coming. You need not remember this relation. You have to remember the formula for electric field and in the potential. Then automatically this relation will be coming to your mind. Okay. The relation between electric field and the potential is very simple. See the exact same diagram that I have drawn there, right? In potential difference, right? The same diagram is here. So there is plus q charge, there is plus q charge here also. You have to move that charge, so that same parameters are there. So here you have to consider, see here there will be some sort of force, there will be some sort of repulsion force, and here what you have to do is, see here you have to consider that force is equal to charge. Here you have to consider that force is equal to charge. Why are we considering here force is equal to charge? How can you even consider like that? Is it even correct? Like that you can ask. I hope it's visible. This diagram is visible. If this diagram is not visible, don't worry. Already the diagram I've shown you, I've explained it in the first part itself. That means in the first clip of the video itself. Okay. See, this is 1 coulomb, right? So this is some charge. Here it need not be that 1 coulomb. Here it can be some charge, but here it has to be 1 coulomb. So what is force formula? Force is equal to, I will erase this part. Okay, 1 by, oh sorry, just k. Okay, k into q1 q2 whole divided by r square, right? Okay, just r square, right? Here it is x. So since it is here x distance, from here to here only you are moving. So to move from this place to this place itself, there will be some sort of repulsion. So here it will be dx square. No, x square only. Sorry, it will be x square only. Okay, so x square will be here. So this q2 is actually 1. Okay, it is, this q2 is having 1 as its magnitude. So if you are taking here 1, so then what will be k into q1 whole divided by x square is what it's going to be. So this is what the force value. Okay, this is what the force formula is going to be. Then in the next case, electric field is equal to k, that means a constant, which is then q1. q1 is the source charge. So k into q1 whole divided by r square. Here also this is what it's going to be. So see, compare this and this. These two are same rate. So electric field and then force is same rate. So that is why we can take it as force and then this electric field. Okay, these two are same quantities. I hope my face is very visible. Okay. So here what you can, the formula is voltage is equal to minus of electric field into displacement. Electric field into displacement. Why is there minus symbol? Why is there minus symbol? It is because, see, the required movement is that it should be moving in this direction. Okay, the required movement is that it should be moving in this direction. Okay, but this electric field is acting in this direction. So since these two are completely in opposite direction, so that you have to put a minus over there to compensate it. Okay, so this is how you have got it. But note, this formula will be eligible only if you are having uniform electric fields. Okay, but don't worry, they will not give us non-uniform those things at all. Even if they have given non-uniform, you can use this formula itself. If your teacher has said some other formula for non-uniform, you can go with that one. Okay, So here E is equal to minus dV by x. E is equal to minus dV by x, that you know. Okay, so here that SI unit is going to be voltage per meter. Okay, so for electric field, you can use it as voltage per meter as its SI unit. Okay, so I said right, you can actually easily remember it if you know the formula of electric field and then the potential. What is the formula of electric field? Electric field E is equal to K into Q naught whole divided by R square. I have said right. So here voltage is very simple. It's actually K into Q naught, Q divided by R. Okay, Q divided by R. The one and only difference is that here it is having 1 hour extra. Okay, here it is having 1 hour extra. Okay, here it doesn't have that 1 hour. So if you are dividing this electric field, if you are dividing this, so if you are multiplying to this electric field with 1 hour, okay, if you are multiplying to this electric field with 1 hour, so this hour, this square will be cancelled, then at last you'll be getting this formula. So that is why they have multiplied here 1 hour. Actually, S is what? Distance. R is what? Also distance, right? Okay. Okay, so I think we are moving pretty good. Okay, because after this I have to also take capacitance. I don't know why, but physics is the one and only one-shot video that is at present going on. Only one biology video I've taken, and then other than that, I'm focusing on only other subjects. Okay, so here you are having the derivation. Okay, one of the most important derivation. So here it is actually what is nothing. Okay, see, voltage due to point charge. Okay, so before going into this concept, I so badly want to give you some basic knowledges. I don't know why my heart is saying that it's very important. So what is the voltage? What is EMF? What is potential difference? What is potential? All these things is now we are going to see the difference also you'll be seeing. Okay, it's very basic. You must know it. Okay, in order to top this lesson. Well, I'm not saying that I'm in the top. Believe it or not, I'm very, very, very weak in numericals. And also coming to question papers in answering the questions, I'm very weak. Just I know the theory. Okay, so don't think that I'm very good in physics. I'm not. Okay, so the thing is now what we are going to do is we are going to check about the potential. What is the potential difference? Potential difference should be between 2 points. That means here is a point, here is also another point, here is also another point. From this point, okay, it is having plus q plus 1c charge, it is having plus q charge. So from this point to, if you are moving to this point, in that case there will be some sort of repulsion forces. So you have to do some work done in order to bring this charge from this point to this point. So that particular work done is what known as potential difference. Okay, so then what will be potential? So here is plus q charge. Okay, and then there is another point over here that is infinite. So from this point to, you have to bring it to this point. Okay, so there will be some sort of repulsion force here also. So when it is actually coming from infinite to this point, then that is known as electric potential. Okay, then that is known as electric potential. Then what is voltage? Voltage is something that you can say it as just the charge. Sorry, it is just the force. Okay, you can say it as just the force, or you can say that it is the amount of work done that is required to bring one unit positive charge from one point to another point. Okay, against the force. Okay, against the force that is produced by plus q charge also, you can say, or you can just say it as a force. It is a form of force. For an example, this is a circuit. Okay, so here is a bulb. Normally I get it a lot in my class. Okay, bulb is there. So in this is a circuit. Okay, let us take this as positive, negative, all these things is there. Okay, so now this battery is connected. Okay, when the battery is not connected, it will be drawn like this, right? Okay, so now here this battery is connected. You can take it as it is connected. So this is plus q charge, this is plus charge, this is minus charge. So from here there will be some sort of force. Okay, here I'm not taking the conventional current. Here I'm not taking conventional current. Here I'm taking the electric current, so that here it will be going in this direction only. So it's going on like this. So see, electrons will be normally before this battery is connected also, electrons will be there in this wire. But when this battery is connected, there will be some sort of force. Okay, there will be some sort of force that is created by the battery to push it. Okay, to push all these electrons from this point to push it out, there will be some sort of force. So that force is known as EMF. Okay, so that force, okay, the force that is produced is what known as actually EMF. When it is actually in this terminal, we'll be saying it as EMF. Then when will you be saying it as potential? Okay, so when you're taking it between two terminals, between this terminal and this terminal, it is set as EMF. But when you're taking it between 2 points, this point and this point, then it is set as voltage. Okay, it is set as potential difference, all those things. Yes, perfect. Voltage is also a force when B. Oh. Okay, I hope I'm explaining pretty good. If you're having some doubts, you can absolutely comment it in the comment section. Okay, then the next thing that you have to know is, see, voltage due to point charge. So the same diagram, only there is this point A, there is this point B, then there is this plus Q charge, and also there is this charge at infinite point. Okay, so here I'm going to explain this diagram first. A lot of people will be confusing in this diagram itself, but this is very simple, believe it or not. This is point O. Okay, you have kept in point O. I'm just flying, I can feel it, but I like it. Okay, so this is point O. In this point O, you have kept a charge that is actually plus Q, and then here this is actually in point A, and then this is point B. So you have to, this is here, it is actually having some charge. Okay, here you can take it as it is having sorry, unit charge. Okay, so from point A to point B it's going, so the distance between point A and point B is going to be dx. Okay, from this point to this point it is going, and the distance is going to be dx. Okay, so and also you have kept another charge. Okay, that is unit charge, positive unit charge. So that is at infinite distance. So you are bringing it from infinite distance to this Q point. Okay, to this point of Q, to this Q point. Okay, both are same only. Okay, so in that time also there will be some sort of repulsion force that will be acting to bring this charge from point A to point B. Also some repulsion force will be acting to bring this positive unit charge from infinite point to this Q P point. Also some force will be acting. Okay, so the force that is acting here will be less. I have already said this. The force that will be acting and potential difference will be less comparatively in the potential. Okay, in the potential. This I have said in the very beginning itself of this video. In the first clip itself, it is there. Okay, so I have already given this formula, that is dV is equal to minus E dx. Okay, so this one point, it is very important. I forgot to say this. Okay, so because of this particular formula, okay, because of this formula is there, right? Because of this formula, this total potential, okay, this electric field itself, okay, so this, because of this formula, it is given a statement. Okay, there is a statement that is negative potential. Okay, negative gradient of potential, negative gradient of potential. That is why this electric field is actually known as negative gradient of potential. Also you can say it as negative gradient of potential. What is also known as electric field is also known as negative gradient of potential. Okay, see, so dV, here all you are going to do is, you are going to substitute the electric field's formula in this formula. See, electric field is having its own formula, right? So you have to substitute that formula in this total equation. So you are going to get minus 1 by 4 pi epsilon naught into q by x square into dx. Okay, so I have already said that you have to do integration, right, in the first clip itself. So you are going to do integration over here. So integration is that you have to put, first you have to put this form, simple, oh god. You have to first put this symbol. The lengthy, skinny, yes, like me. Okay, it's skinny and it's lengthy, right? So, yeah. So you have to put it over here is equal to integration of, so the upper limit is going to be r. I feel like you guys can't see it. Okay, so upper limit is going to be r and the lower limit is going to be infinite. So here minus symbol, 1 by 4 pi epsilon naught q by x square into dx. So here you have to take all the constants outside. What are the constants? Negative should be first taken outside, and then 4 pi epsilon naught is also a constant that has to be taken outside. Also q should be taken outside because q is also a constant. You cannot change q. Okay, so then what will be remaining inside? The thing that is remaining inside is going to be the integration. Inside the integration, it's going to be 1 by x square into dx square. Sorry, into dx. Okay, so here you have got a formula. Actually, you have got a formula. The formula is that this one. See, 1 by x square into dx. When you are having something, a condition inside this integration, okay, then what you have to do is, it can be written as minus 1 by x. It can be written as what? Minus 1 by x. Okay, so here I have written as minus 1 by x, and then here it is actually upper limit, lower limit. When you are cancelling integration, so since there I have cancelled integration, So when you're converting this, see, notice when it is inside integration, when it is actually inside integration, actually when it is inside integration, it has to be written like this. So then after, from this integration, if you're taking out, from this integration, there will be upper limit, there will be also lower limit. Okay, lower limit and then also upper limit. Okay, so when you're taking it from this point and you are putting inside, from when you're cancelling this integration, then you have to put it into square bracket, okay, closed bracket, and you have to write here the upper limit, okay, and here you have to write the lower limit. Okay, here you have to write it in this place, here you have to write it in the right place. Okay, so next what you have to do is you have to okay, so you have to cancel here this minus and then this minus, and then at last you'll be getting as q by 4 pi epsilon naught open bracket, okay, open closed bracket, this bracket is also said as closed bracket, okay, open closed bracket, 1 by r. So in this place of x you have to substitute this r, and then you have to subtract it, upper limit minus lower limit. So first you have to substitute in this place of x, you have to substitute r, so minus 1 by infinite you have to put over there. Okay, so after that r is equal to, so r is equal to q by 4 pi epsilon naught r, because 1 by infinite is going to be 0. So 1 by r minus 0 means nothing, that means 0 is nothing, right? So 1 by r I have just taken, and you are multiplying this 1 by r with this one, so you are going to get this one. At last r is equal to kq by r. What is this r? There are two r's. Okay, sorry, I forgot to differentiate this r and that r. I have written like that itself. Okay, actually that is not r, that is actually v, but as the time goes, I have started writing it as r. Then just look at my presence of sense. OMG, I'm so proud of myself. Sorry, here it has to be v. Oh god, oh god. Okay, now we have changed it. We all do mistakes, right? So we have to not to be harsh on ourselves. We have to be kind on ourselves, mainly on me. Okay. Next is equipotential surface. Actually, this one I can remember. I was writing this at 12 o'clock. Okay, I was on half sleep. I was actually kind of distracted, but now I'm completely towards you all. So if there is any mistake, I will change it all by myself. Okay, so what is equipotential surface? It is a surface where the potential points in that particular shape will be same. Okay, for an example, see, first, what is this word equipotential surface mean? Surface means what? It is going to be a plane, okay, xy plane, or it can be circular plane, something, it's going to be a plane, that's it, okay. Plane itself means what? It is going to be xy. Okay, so equi means what? Equal potential. So this particular surface is having equal potential. That is what we'll be saying as equipotential surface. Okay, I'm using the word a lot, okay, right? Because I want okay from a lot of people. So the definition of equipotential surface is going to be if all the points on the surface are at same voltage, then we'll be saying it as equipotential. Oh god, I'm very thirsty. Okay, I have drunk water. So see, this is a you can take this as a plane. Okay, so this is a plane. It is actually having equipotential. So in this plane, what you are going to do is there is plus q charge. Okay, there is plus q charge in the center of this plane. Okay, and then this plane, if you are drawing circles in this plane, okay, I have drawn here. See, two circles I have drawn. I have drawn my marks. Okay, so I have drawn here two circles, right? Okay, so if you are taking potential of these two circles, So the potential with this circle and then the potential with this circle. So the potential that is with this small circle will be actually 0. If you're taking potential at any point of the circle, at any point of the small circle, it is going to be 0. That means potential of A is equal to potential of B is equal to potential of C. Okay. And the second thing is, if you're taking the second circle, that potential is also going to be equal to potential of H is equal to potential of D is equal to potential of E is equal to potential of F is equal to potential of G. But remember this one point, potential of A is not equal to potential of D. Okay, so the potential of this circle is not equal to potential of this bigger circle. That is something that I have to know, that I have to say. Okay, so this forms, okay, see this plus q charge forms if you are keeping plus q on a plane surface, and if that surface is actually equipotential, then that forms concentric circles. Okay, that will be forming concentric circle spheres. Okay, in 3D it will be forming concentric circle spheres. In 2D it will be forming only concentric circles. Okay, I don't know why I cannot talk. So here, since potential is constant, here all the places potential is constant. So what you can do is that we know this formula. So this, since this is related with points, what we'll be saying it is actually potential difference. It's very sweaty over here. I'm sweating. Okay, so that is why I'm rubbing myself. So E is equal to minus dV by dx. What is it is said as? It is said as negative gradient of potential. I've already said. If you cannot remember, remember it now. Okay. So now I'm going to put integration over it. So integration of dV. That means I'm here integrating V, which is constant. So integration of any constant is going to be 0 only. So here the electric field is actually 0. Okay. And also the work done is also going to be 0 only, because if you notice here, it is actually work done is equal to Q into V only. I have already said it. Okay. So Q into V, did I say? No. Work done is equal to Q into V. I didn't say. Now you can say that work done is equal to charge. No, I said. Sorry. I forgot. Okay, I said this. Voltage is equal to work done per charge. I said. So here you can say that work done is equal to Q into V. That particular point I think I didn't say, but I said that voltage is equal to work done per charge. Okay, so here voltage, if I'm taking it as old potential difference, then that will be voltage of A minus voltage of B. So if I'm taking in this circle and if I'm taking a potential difference, so I have to subtract the voltage that is here and then you have to subtract the voltage that is here, right? So when you're subtracting, it will ultimately resulting you 0, because VA is equal to VB. So when you're subtracting two same things, that means 1 minus 1 is 0, 2 minus 2 is 0, right? So like that, when you're subtracting it, it is going to be 0. Okay. If you are feeling that my English is kind of fast, please slower the video. There is option in YouTube in this right side of this total, that YouTube screen. In this right side there will be settings. If you are clicking there, then it will be showing the speed. So if you are clicking the speed, you can just decrease or increase the speed. So like that you can alter for your wish if you are feeling the English is very fast, because I have an examination tomorrow and it has portion in it. I have to cover 2 different lessons, so that is why I'm going very fast. Okay, so next is this one lengthy rod. Okay, next is this one lengthy rod. So in this lengthy rod, it is actually having plus charge. Okay, so this all these electric fields will be outside. In the first lesson, even I've said it. So it's actually linear charge. Here, if you are taking the equipotential, it will be actually cylindrical. It will be cylindrical. Okay, so then the next concept is that potential energy due to two charges, or you can also say that potential energy due to dipole moment, like that you can say. No, here it is not dipole moment. Dipole moment it is coming. Okay, here it is capacitance. I think I have to write about dipole moment also. It's very important. In JE, they have asked one time, not they have asked the formula. Okay, so electric dipole due to electric field. Okay, something like that. Electric potential, something like that. I forgot the. I will just write it. Okay. Potential energy due to two charges. That means here, see, this is actually point B. Okay, so in this point B at present, in the first stage, there is no charge. Okay, and then this is point A. So to this point A, you are bringing this Q charge to this point A. Okay, so now this point A is having Q1 charge, and then this point B, towards this point B, you are bringing Q2 charge. Okay, so Q1 and Q2 both are repelling, because what will be happening? This is also plus Q. Okay, this is also plus Q. So they both will be repelling, but note that Q1 and Q2 need not to be the same. Okay, they need not to be the same. Okay. So we already know that voltage, or sorry, the potential is actually equal to work done. In the first clip itself, I have said that, right? So here potential energy is equal to work done. So work done, first we have to calculate. So the total first, in order to get this potential, what we have to do? We have to get that work done. So what will be the total work done? See, total work done is going to be W net is equal to W1 plus W2. Okay, so here if you're just checking it out in the first case, okay, this is for the first case and this is for the second case. This is in this first case, since there is no repulsion at all, there is completely no repulsion. Why is there no repulsion in the first case? Because point B is neutral point. It doesn't have any positive charge, nor it doesn't have neither positive nor negative charge. So to bring this Q1 charge from infinite, or yeah, so from infinite or from a point to this point, it will not take any work done. It will not take any work done. Okay. So here voltage is equal to 1 by 4 pi epsilon naught into Q1 by R. Okay, Q1 by R. I think I didn't say how we got this formula, the formula of voltage, that also I'll be saying, okay, and also I have still two different derivations, totally three derivations that we have to see now. We will be checking it out. So voltage is equal to 1 by 4 pi epsilon naught Q1 by R. So here the R distance is there, right? You can say that R distance, okay, since this from this point to this point is actually infinite, right? So this R is going to be infinite. So that means this total point, you can say it as the total thing as 0. This total thing as 0, because Q1, anything divided, okay, anything that is in the numerator with respect to infinite is going to be 0. So that means this total term is going to be 0. So when you are multiplying this total term with this k, then that is also going to be 0 only. Okay, so work done is equal to 0 in this first case. In the second case, that is work done is equal to Q2V. Here work done is equal to charge into voltage, we know. Here the charge is going to be Q2, because Q2 is the charge that is coming here. Okay, so here Q2 is the charge that is coming here. You have to always take the charge that is over here. You should not take the charge that is here. Okay, but in the voltage you have to take Q1 only, because this is what, this Q1 is what repelling, right? So the repelling charge should be taken in voltage, and the charge that is over here is there, right? That has to be taken in this way, that is the moving charge has to be taken as this charge. Okay, so here you can say this as work done is equal to Q2 into Q1 whole divided by 4 pi epsilon naught into R. Okay, so now if you are just substituting in the values, W net is equal to W2. Very simple, right? Okay. Okay. Now, what we are going to do is we are going to derive formulas. Okay, so what formula shall we derive first? We are going to derive potential energies formula. Okay, voltage formula. Okay, I'm so sorry for external noises. Now we will be going to potential energy due to point charge. Okay. So even I haven't by hearted this derivation, so I'm just going to explain it. Okay, so potential due to a point charge. Okay. So what is it actually? See, there is actually plus charge in this place. Okay, this is a point. Let us take this as point A. Okay, so now what we are going to, now first I will be explaining this. So it is actually there is a plus charge, okay, and this point is actually A, and with some distance there is a point, this is point B, and then with again some distance there is point C. Okay, where is this Q charge which has come from infinite. Okay, which has come from infinite. Now actually the same diagram, okay, the same diagram only here it is also, okay. And hmm, hmm. Okay, so like this total distance from here to here be r dash, okay, and then like this total distance from this point B to this point C be delta r dash, okay. So this charge from infinite to point C has come, right? It has to also go to point B, okay, it has to also go to point B. So like this B r, okay, let this be r. So as I said that it has to come from infinite to point B only, but now at present it is in point C. At present it is in point C. In the midway it is there. Okay, now we have taken a picture where it is in the midway. Now I am going to explain it. Okay, so work done is equal to work done is equal to force into displacement. We know this formula, right? Okay, I'll grab my spectacles. I can't see clearly. Well, I can see clearly, but the thing is, without my spectacles, I feel half. Okay. Okay, so work done is equal to force into displacement. Here, since work done is in this direction, work done is in direction, and force is in this direction. Okay, so it is going to be negative. Here you have to put a negative symbol. Okay, so here if I am inputting the force value, see actually it is d, sorry, dw. I'll write it in blue color in order to differentiate it. dw is equal to force into d, okay, force into dr. Okay, here negative. Now what we are going to do, now we have to integrate whenever this d, whenever you are seeing this d itself, we have to integrate this one. Okay, so integrating, what you have to do here, force, what force is it? It is actually repulsion force. We know one thing, always repulsion force will be like how? Positive. Yes, right. Okay, actually sometimes I just get doubts. Okay, because sometimes I write wrong. Not sometimes, literally all the time I'll be writing wrong. Okay, see, from infinite to this point it has to come, right? So what is the upper limit going to be? This is what the upper limit is going to be, r, and infinite. From infinite only it is coming to r distance. Okay, so integration of dw is equal to minus integration of, here it is infinite, and then here it is r. R, which is, see here force is actually 1 by 4 pi epsilon naught into q1 into q2 whole divided by r square. Here this is what you have to put. Okay, here r square, no, this total distance, because charge is here and this charge is here, so this total distance only you have to put. So it is r dash square, this is r dash square, okay, into delta r. This dr I can write it as delta r, right? So delta r. Okay, so now I'm going to take all the constant out. So if I've taken all the constant out, then how it will be? Work done is equal to minus q1 into q2 whole divided by 4 pi epsilon naught. Okay, and infinite r whole divided by r dash square into dr. Okay, dr. This is how it's going to be. Okay, see, I've already said here. Here even I've said. What did I say? Here I have given this particular thing, right? So now I'm going to explain how did this point come? Okay, from what did I derive? That I'll be saying now. See, whenever you are having like this, okay, so I'm just going to take this particular term, this term I'm going to take. Okay, so integration infinite r 1 by r dash square into dr square, right? Okay, so now I'm going to take it up. Okay, from this point to this point I'm going to take it as, so r dash minus square into dr I'm going to take it as. So now what I can do now, I have to reciprocate it again. R, sorry. Okay, so r to this r minus 2 is the power. So you have to take this power and you have to write it over there. And you have to add 1 over here. And what you have to do, the same thing you have to do it to the denominator. Minus 2 to plus 1 you have to do. So it will be r to the power of minus 1 by minus 1 it will be. Okay, done, all done. So now this can be taken here and this will be coming up. So minus 1 by r. Actually this won't come up, but I said it. Okay, so I'm going to write it over there. Work done is equal to minus q1 into q2 whole divided by 4 pi epsilon naught. Integration of this is infinite, this is r. Okay, this is 1. So I'm going to substitute this value. Oh, sorry, not integration. Here I have to put a box. Whenever I have already said to you, whenever you're taking out this integration, it has to be put in box, 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 box. Okay. So how many of you guys like the boxer dog? I like the boxer dog. I like dogs. So this one you'll be getting. So this plus and this plus can see this minus can be cancelled out, and then work done is equal to q1 by q2 whole divided by 4 pi epsilon naught into, here it can be said as 1 by r. Okay, so if you have noticed here, I have already said to you all that here this is always going to be, this charge is going to be 1 coulomb only. Okay, and I can take this as q charge. Okay, I can take this as q charge. So here let q1 be q. Okay, positive q. That means let q1 be this q. Okay, and q2 is going to be 1 plus 1. Okay, so how is this formula going to be? Work done is equal to big Q. Okay, whole divided by 4 pi epsilon naught into 1 by r. So this is how the formula is going to be. This is how the work done. So work done is equal to voltage. So voltage V is equal to, at last we have derived the formula. Voltage is equal to Q whole divided by 4 pi epsilon naught into 1 by R. Okay. Finally, last derivation. Yeah. We are dealing with a lot of derivations. I know that. So this is going to be the last derivation. So what is in this derivation? See, this is not something that they are normally asked, but this is kind of high level, I can say, because I felt it kind of very hard to understand. Personally, I have to accept it. Okay, I felt it as kind of hard, very hard to understand. Not very hard, little bit hard. Okay. So this is electric potential due to electric dipole. 10 minutes. Okay. See, the thing is, so that's my mother actually. Okay, so there is actually this plus Q charge. I don't have a camera, so I am using her phone since her phone is having a pretty good camera quality than any other phone. My father is having Apple phone, but he's not quite around the home, and also he's not a person who likes me to put videos on YouTube. Okay, so yeah. So see, plus Q charge is there, minus Q charge is there, and then there is this distance of separation where I'm going to take this as point P, and then this is A distance, and then this is also A distance. Within 10 minutes, I'll be completing the video. Not because of she asked for the phone, because my legs are paining. Okay, so yeah, so this is point P, all of this. So this total distance can be said as 2a. Okay, this total distance can be said as 2a, and so the dipole moment is going to be here. Okay, sorry, I will be taking this as point P. Okay, here if I'm taking this as point P, I'll be taking this 0. Not dipole moment is not there. Here it is 0. Here I'm going to take it as point P. Okay, so I'm going to connect it. First I'll be explaining what is this. Okay, electric potential due to electric dipole. That means this is point P. So this dipole will be creating some sort of electric potential. Okay, so it will be creating some sort of electric potential. That is what we are going to calculate. So for that, this is the dipole moment. Okay, this is what the structure is. So here I've taken a point. So I'm going to check the electric potential. I'm going to check the electric potential at this point P. We can say like that also, right? Okay. So how are we going to check it out? First, this charge will be having some effect on this point P, right? Okay, so same, this charge will be also having some effect on this point P. Okay, so I'm going to connect, yes, right, it's very obvious, it's very, very obvious. So I'm going to connect from this center point to this point. Okay, so like this I'm going to connect it as. So here I'm first, what is the formula of voltage? What is the formula of voltage? It is actually voltage is equal to 1 by 4 pi epsilon naught into 1 by, okay, so Q, so this Q and B, so this Q by R1, okay, so this is what R1, what I'm going to take it as R1 is, this is what R1, this is R2, okay, let this be R, let this distance be R, let this be R1, and let this be R2, okay, minus Q by R2. Actually we have to add one B, but since this charge is minus, so actually there would have been here plus, and like this only it would have been, okay, wow. So since this minus and this plus, if it gets multiplied with, then it'll be like this, okay, then this is what. So now what I have to do is, we have to find the R1's formula, okay, we have to find R1's formula. So R1 is equal to, I'm writing everything very big, bada sizes. Okay, so R1 square is equal to R2, okay, R square plus A square minus 2AR cos theta, 2AR cos theta. How did this come? Okay, see, this is something that this was the part that was kind of tough for me to understand, because law of cosine is the thing that is being followed. Very simply, you can say it as law of cosine, but I'm not a person who's going to say that. Because of law of cosine, you have got this. Okay, we are going to with the how did it come? Okay, I'm talking like a person who knows very good physics, but believe it or not, I'm not. Okay, I've written here. So before going to that point, I have to say a few points. That is, I'm going to construct here. Okay, I'm going to construct here. In order to find this R1, I have to first do construction. Here the construction is that here it is actually theta. Okay, and then here it is perpendicular. Here it is 90 degrees. Here it is 90 degrees. So I'm going to take this triangle alone. Okay, I'm going to take this triangle alone. If you are taking this triangle, how it will be? See, little bit like this, like this, like this. So perpendicular theta. Here is where this plus Q is there. Okay, but I'm not going to write this. So R1 is here, R1. So this is what this total distance is, what R2. Okay, so this is what, sorry, R1. So this is what R, this total distance is what R. Okay, so this particular point I will be writing it as A cos theta. Why it is written as A cos theta? because this distance is a, okay, because this distance is a, right? Okay, from here it is all very easy, it's very easy. So what is cos theta? Cos theta with respect to this, okay, it is actually so since this is what perpendicular is, so here I can say it as a into this particular, sorry, this distance. So adjacent by hypotenuse, adjacent by hypotenuse, which is going to be this one. So I can write it as, what is adjacent over there? Some distance, okay, this adjacent bx, okay, let this distance be x over here. So if it is x over there, then that means, so here this x is equal to a cos theta. Okay, so a cos theta you have got, in place of x, if you are substituting a cos theta, you have got this. Okay, so since this total distance is r, I can write it as r minus a cos theta, right? R minus a cos theta. Okay, okay, all done. So r1 square, according to Pythagoras theorem, so r1 square is equal to this distance. Okay, so which is actually a sine theta over here. Because see, very simple, let this distance be y. Okay, this total thing be y. So in that case, y is so if this is y, so sine theta, sine theta. So with respect to this theta, what will be this y? So it is going to be opposite y by a. So this is a sine theta is what y, right? Okay, so I've got y also. So in this place of y, I'm going to substitute as a sine theta. Okay, this is a cos theta, this is a sine theta, this is just the a. Okay, so here r1 square is equal to, so this is what the hypotenuse is. So I'm just adding this and in this, that is r minus, wait, yeah, correct only. Okay, so a sine theta the whole square minus r minus a cos theta the whole square. Okay, so a square sine square theta, so this total thing minus r square plus a square cos square theta minus 2r a cos theta. Okay, so now this is going to be a square sine square theta minus, okay, minus r square plus a square cos square theta minus 2ra cos theta. Okay, so now what we are going to do is, see this and then see this. Okay, so if I take a square common in here, a square, so this will be sine square theta plus cos square theta, right? Minus r square minus 2r a cos theta. So this total term will be 1. This total term will be 1. At last what we'll be getting, sorry, plus. So the only thing that will be, sorry, very sorry. I don't know why. In which word was I? Where? So plus. So I've multiplied over here. So r square plus minus. Perfect. Appa. There I didn't do that. Okay. So we have taken here. So this and this. So plus and minus. Okay. So this exact term only I have written over here. Yes, right. This is what I have written over here. So a square, so this total term will be 1. So see, just a square I have written, r square minus, like this I have written. Okay. So I'm going to just erase all of this as it is not, it is required, but you can write in your notes in a separate way. Okay, so we have got it. We have got this, right? I know you are thinking that what is this boy doing? He's just now searching the notes. Okay, he didn't even by heart the derivation. Sorry. Okay, so what I'm going to do is, see, r1 square. So here I'm going to divide it with r square. Okay, here I'm going to take this r square as common. So that means r1 square, r dash r1 square is equal to r square, if we take it as common, 1 plus a square by r square minus 2a cos theta by r is what I'm going to get. Okay, so here you have to note that r is actually greater, very much greater than a. So this distance r is very much greater than this distance. Always we know the dipole distance will be very less. So just know this one. Okay, so because of that itself, this total term has to be neglected. This total term has to be neglected. If it is all neglected, it will be r1 square. Okay, it will be r1 square is equal to r square, open bracket, 1 minus 2a cos theta whole divided by r. It's all, it is r, it is not 2. Okay, see, this r and this r is same, and do not think that this r is different because I've changed the font. I don't know whether you can understand this is r, or you might think it as also 2. Okay, so here now what I'm going to do is I'm going to take it as root. So r1 square is equal to r. So if I'm taking it as root, so that means root. Okay, so r1 is equal to r, open bracket, 1 minus 2a cos theta whole divided by r into 1 by 2. Okay, now I'm going to reciprocal it. So r dash is r1 is equal to 1 by r1. Oh, what I'm doing? 1 by r1 is equal to 1 by r, open bracket, 1 minus 2a cos theta whole divided by r into minus 1 by 2. Here it was plus 1 by 2, here it is minus 1 by 2 since I've reciprocal it. Then at last what I've got here is, we know this formula, that is 1 minus x to the whole power of minus n. Okay, this is actually binomial theorem, which is equal to 1, this will be coming before, so plus nx. Okay, plus nx, like that you can write it as. So now I can write it as 1 by r1 is equal to 1 by r whole bracket into 1 plus a cos theta whole divided by r. Okay, so I've got this one. Okay, so exactly similarly like this only. Okay, so like this I've got up. So exactly similarly like that will be 1 by r2 will be also there. Is equal to 1 by r, open bracket, 1 plus a cos theta into r. Okay, similarly like this only it will be also, but the one and only thing that differs is here will be minus. Okay, just to do the same thing. How much I've done here, right? So do the same thing, same derivation for r2 also, then you will be getting, okay, then you will be getting like this. Okay, if you want, I'll be saying the first equation for r2 alone. So here like this for r2 also it will be there, right? That equation is going to be r2 square is equal to r square plus a square, okay, plus 2ar cos theta. Okay, so now we have got r1 and r2. See, r2 I've got, r1 I've got, r2 I've got, and I've also got this major formula. Okay, so if I substitute r1 and r2 in their respective places, then what will I get in my final formula? In my finalist place, what will I get? I'll be getting voltage is equal to, at last this is what the formula, 1 by 4 pi epsilon naught into 2aq cos theta whole divided by r square. This is what the final formula is. So this is what the voltage that is created by a dipole moment. Okay, so that's it. Sorry, I've gone here and there in this video a little bit and I've paused it. So thank you, bye bye. We'll be meeting you in another amazing video.